Welcome to another deep dive. This time, we're taking a closer look at holmium.
Holmium.
And we've got a whole bunch of sources lined up.
Oh, cool.
Yeah, we've got some historical excerpts, we've got periodic table data, we even found a scientific podcast episode
Okay.
all about holmium.
Wow.
And it's going to be fascinating because this element is, well, it's anything but rare. In fact, get this, holmium is actually more abundant than silver.
Really?
Yeah, I was surprised too.
I had no idea.
So we're going to be exploring that unexpected abundance. We're going to go back to its discovery, and we're going to dive into some of its pretty mind-blowing applications.
I'm intrigued already.
So if it's not so rare, how was holmium even discovered?
Yeah, it's fascinating how perceptions can be misleading.
Right.
You know, that term rare earth, it kind of throws people off.
Yeah.
But when you look at the numbers, holmium is actually more common than we think.
So how was it discovered then?
Well, like a lot of elements, holmium was discovered through spectroscopy back in 1878.
Wow.
And there were actually two separate teams working on this, one in Switzerland and the other in Sweden.
Okay.
And they were analyzing light spectra.
Okay.
And they stumbled upon some unusual lines that didn't match any known element.
So it's like they were putting together a puzzle, but using light as the clues.
Exactly.
Wow.
These spectral lines, they acted like a fingerprint, revealing the presence of a new element.
That's pretty cool. But the two teams at the same time, though, it sounds like it could have gotten competitive.
It wasn't actually that uncommon back then, especially with these rare earth elements.
Okay.
You see, they have very similar properties,
Right.
which made them tricky to isolate.
Okay, yeah.
So often you'd have multiple discoveries happening around the same time.
Gotcha. So who actually got the naming rights?
Well, the Swedish chemist, Per Theodor Cleve,
Okay.
he got the honor.
Right.
He named it Holmium after Stockholm,
Oh.
his hometown. The Latin name for Stockholm is Holmia.
So not the most imaginative name, but it does the job.
It's stuck.
Yeah, it works. So what does this Stockholm-inspired element actually look like?
Well, picture a bright silvery metal.
Okay.
When it's freshly isolated, you know, it's got a nice sheen to it.
Shiny. So are we talking like precious metal vibes?
Yeah.
Could I like fashion a holmium ring?
Hold on now, hold on. It's not as resilient as, say, gold or platinum.
Okay.
Holmium, it tarnishes when it's exposed to air.
Oh.
It forms this yellowish oxide coating.
So like iron rusting, but with a yellowish tint.
That's a good way to visualize it.
Okay.
Yeah, it's all about oxidation.
I see.
Holmium reacting with oxygen in the air.
Chemistry in action. Okay, so let's talk about something that's truly mind-blowing about holmium.
Okay.
And that is its magnetic power.
Mm.
This element boasts the strongest magnetic force of any element.
That's right.
Did I hear that right?
You did.
Wow.
But there's a little nuance here. Okay, so holmium is a paramagnet,
Okay.
meaning that it needs an external magnetic field to actually become magnetic itself.
Yeah, okay.
It's not like those permanent magnets, you know, you see on your fridge.
Right.
Those are a little different.
So it needs a little push to unlock its magnetic superpower.
Exactly.
Okay.
But here's where things get really interesting.
Right.
Below 19 Kelvin, and that's super cold,
Yeah.
holmium turns into a ferromagnet.
Ferromagnet. So does that mean it becomes like those fridge magnets, staying magnetic even without that external field?
Precisely.
Wow.
At those ultra-low temperatures, holmium becomes a ridiculously powerful permanent magnet.
Okay.
We're talking magnets that are used in research labs, medical imaging,
Oh, wow.
even those high-speed trains.
Really?
Yeah.
Wow. Okay. So holmium magnets, they're heavy hitters. But let's dive into a mystery that intertwines holmium with fundamental physics.
All right.
And that is the quest for the elusive magnetic monopole.
Ah, yes.
This is where things get really intriguing.
You know, this is where things get really intriguing.
Okay, so imagine a magnet,
Right.
but it only has one pole, either north or south, but not both.
Okay.
That's the monopole.
Right.
And finding one, that would turn our understanding of physics upside down.
It would be huge.
Hold on. Why is a single-poled magnet such a big deal?
Yeah, I mean, it seems like kind of a minor detail.
Right.
It's far from minor.
Okay.
Current physics dictates that magnets have to have two poles.
Okay.
Finding a monopole would rewrite the laws of electromagnetism,
Wow.
potentially even lead to breakthroughs in fields like particle physics, cosmology, you name it.
So how does holmium fit into this scientific treasure hunt?
It challenges everything we know.
Yeah, that's a pretty big deal.
Well, there have been some tantalizing hints,
Okay.
but no definitive proof just yet.
Right.
Back in 1982, there was a physicist who thought he had found a monopole.
Oh.
But the experiment couldn't be replicated.
Okay.
And then fast forward to 2023, scientists observed something that resembled monopoles
Oh, wow.
in holmium titanate crystals.
So they saw monopoles.
Not exactly.
Uh-huh.
What they detected were formations that acted like monopoles under certain conditions. Think of it as seeing a shadow of the monopolars rather than the real deal.
Okay.
The mystery continues.
So the search for the monopole is still on, and holmium might be the key.
It's certainly a contender.
Okay.
And it's not just the world of magnets where holmium shines.
Okay.
Let's move on to its surprising role in nuclear reactors.
Nuclear reactors. That's a twist. I wouldn't have guessed that.
Yeah.
What does holmium do in that environment?
Well, holmium has an incredible appetite for neutrons.
Okay.
It's so good at absorbing them, in fact, that it's used as what we call a burnable poison in nuclear reactors.
Burnable poison.
Hey!
That sounds intense. What does that even mean?
It's actually a clever way to control those chain reactions that happen inside a reactor.
Oh, okay.
Think of it as like a safety mechanism. Holmium soaks up those excess neutrons and prevents the reaction from going out of control.
Right.
And as it absorbs them, it gradually it burns up.
Okay.
And that allows for fine-tuning of the reactor's power output.
So it's like a neutron sponge, keeping things in check.
A very specialized sponge.
Okay.
And what's remarkable is that holmium isn't alone in this.
Okay.
Other rare earth elements, like gadolinium, they also play this role.
Okay.
But holmium stands out because of its efficiency in capturing those neutrons.
Gotcha. From powerful magnets to nuclear reactor control.
Mm-hmm.
Holmium's versatility is pretty remarkable, but wait, there's more.
Oh,
It's even used in lasers.
that's right.
Specifically, holmium-doped lasers in medicine.
Yes.
Why are holmium lasers so well suited for these procedures?
Well, they emit light at a wavelength that water just loves to absorb.
Okay.
And since our bodies are mostly water,
Right.
this allows surgeons to target tissues very precisely while minimizing damage to surrounding areas. It's like a super precise water-seeking scalpel.
Incredible precision. So holmium is a magnetic powerhouse, a nuclear reactor guardian, and now a high-tech medical tool. What can't this element do?
Well, it doesn't stop there.
Oh,
Holmium also plays a role in those UV spectrophotometers.
okay.
You might have used one in a science lab.
Vaguely, yeah. Those are the instruments used to analyze how much light passes through a substance, right?
Exactly.
Oh.
And here's where holmium's fingerprint comes in handy again.
Okay.
Remember those unique spectral lines we talked about?
Yeah.
Well, they make holmium a perfect reference point for calibrating these spectrophotometers.
So it's like a tuning fork for these scientific instruments,
Yeah.
ensuring accuracy in measurements.
Precisely.
Oh.
Holmium makes sure those scientific readings are consistent and reliable.
Right.
It's kind of a behind-the-scenes role, but a vital one nonetheless.
Okay, so we've covered a lot of ground here. From the surprising abundance of this so-called rare earth element to its incredible applications in magnets, nuclear reactors, even lasers.
It's pretty amazing.
But I have a feeling there's more to uncover. Stay with us as we delve even deeper into the world of holmium after a short break.
Sounds good. Welcome back to our deep dive into holmium. Before the break, we were just about to explore holmium's potential in the mind-boggling realm of quantum computing.
Yeah, quantum computing, it still feels like science fiction to me. How could an element like holmium even help unlock that next level of computational power?
One of the biggest hurdles in building quantum computers is finding materials that can hold on to those fragile quantum states for any decent length of time.
Okay.
And holmium, with its unique magnetic properties, might just be the answer.
Really?
Yeah, researchers are exploring how single holmium atoms could actually act as quantum bits.
Wow.
Or qubits, the fundamental building blocks of information in a quantum computer.
So a single atom of holmium could store information.
It's pretty wild, right?
That's pretty wild. What makes holmium so special in that quantum world?
Well, holmium atoms have what we call a high magnetic moment.
Okay.
Imagine them as tiny magnets with a really strong magnetic field.
Okay.
This allows them to interact with other holmium atoms, even at relatively large distances. And it's this interaction that's crucial for performing those quantum calculations.
Okay.
It enables the entanglement of qubits, which is one of the, the cornerstones of quantum computing.
Entanglement, it's one of those concepts that makes my brain do backflips.
I know, it's pretty out there.
Can you break that down for me?
Okay, so picture two holmium atoms, each one acting as a qubit, right?
Okay.
When they become entangled, their fates are intertwined no matter how far apart they are.
Okay.
So if you measure the state of one, you instantly know the state of the other, even if they're miles apart.
Okay, that's officially bending my mind.
Yeah.
So holmium's magnetic strength is what enables this entanglement.
Right.
And that's key for those quantum computations.
You got it.
Wow.
And, it's still early days in this research,
Sure.
but the potential of holmium in quantum computing is huge.
Yeah.
I mean, imagine breakthroughs in medicine, materials, science,
Wow.
even artificial intelligence.
Right.
All thanks to holmium's quantum quarks.
It seems like every time we turn a corner, holmium reveals a new talent.
It does, doesn't it?
But let's take a step back for a second and revisit its origins.
Okay.
We know that it was discovered through spectroscopy.
Right.
But what does that actually involve? How do you even find an element by looking at its spectrum?
Well, it's all about how light interacts with matter.
Okay.
So when you shine light through a substance, some wavelengths get absorbed while others pass through.
Okay.
And this creates a unique pattern, like a fingerprint for each element.
Right.
We call that its spectrum.
So by analyzing the light that passes through a substance, scientists can decipher which elements are present, like a cosmic barcode scanner.
That's a great analogy.
Right.
Yeah, back in the 1870s, scientists were using prisms and diffraction gratings
Right.
to split light and analyze those spectra.
Okay.
And that's how those two teams, working independently, stumbled upon the spectral signature of holmium.
They saw lines in the spectrum that didn't match any known element.
Exactly.
And they knew they were onto something new.
It was exciting, I'm sure.
Yeah, it must have been.
It took time, of course. But eventually they were able to isolate this new element and give it a name.
It's amazing how these scientific discoveries can unfold over decades, even centuries.
I know, it's incredible.
But getting from those spectral lines to pure holmium metal must have been a challenge.
Oh, it was. It wasn't until 1911 that pure holmium metal was finally isolated.
Wow.
Those rare earth elements, they really like to stick together,
Yeah.
makes them notoriously difficult to separate.
So holmium's journey from those saint lines to a pure metal was a long and winding road.
It was, yeah.
But its story is far from over.
Not at all.
In fact, we've only just scratched the surface.
Absolutely. And, to think, it all began with those two teams of scientists in the late 19th century just meticulously analyzing light spectra.
Right.
It's a testament to that enduring power of scientific curiosity.
Speaking of enduring power, let's talk about those incredible holmium magnets.
Okay.
We touched on them earlier, but I think they deserve a closer look.
Absolutely. Holmium's magnetic strength is truly exceptional.
Yeah.
It has the highest magnetic moment of any naturally occurring element,
Wow.
meaning it generates an incredibly strong magnetic field when it's exposed to an external magnetic field.
So not only is it strong, but it's got some special magnetic qualities that make it, perfect for specific tasks.
You're right. For instance, holmium magnets can handle incredibly high temperatures
Oh, wow.
without, breaking a sweat.
Right.
This makes them vital in high-powered motors, generators, even in particle accelerators, those behemoths of physics research.
So while those fridge magnets might struggle, holmium magnets are out there, pushing the limits of technology.
Exactly. They're kind of the unsung heroes of a lot of cutting-edge technologies, making the impossible possible.
It's mind-blowing how an element that was discovered over a century ago is still at the forefront of innovation.
It is, isn't it?
But let's switch gears for a moment and talk about another area where holmium shows promise,
Okay.
and that is medical imaging.
Yes, holmium and the world of MRI.
Yeah.
As you know, MRI, or magnetic resonance imaging, is this powerful technique that allows doctors to see inside the body without using harmful radiation.
Right, and it's become an essential tool in diagnosing and monitoring a wide range of medical conditions.
Exactly.
Where does holmium fit into this picture?
Well, remember holmium's paramagnetism,
Yeah.
its ability to become magnetic in an external magnetic field.
Right.
Well, this property makes it a potential candidate for use as an MRI contrast agent.
What exactly is an MRI contrast agent?
So it's a substance that's injected into the body before an MRI scan.
Okay.
and the contrast agent highlights specific tissues or organs in the images,
Okay.
making it easier for doctors to spot anything unusual.
So it's like adding a highlighter to the MRI scan to
Exactly.
make things stand out.
Currently, gadolinium-based contrast agents are the most widely used,
Okay.
but there are some concerns about the long-term safety of gadolinium
Right.
because it can actually linger in the body.
That's where Holmium steps in, right?
That's right.
As a potentially safer alternative.
Precisely. Holmium, with its similar paramagnetic properties to gadolinium,
Okay.
could potentially provide the same image enhancement, but without those same safety concerns.
So Holmium could lead to like a new and improved version of this vital medical tool.
Potentially, yeah.
Wow.
The research is still in its early stages, but the possibilities are pretty exciting. And who knows what other medical applications for holmium might emerge as we delve deeper into its properties.
It's a reminder that even after over a century of research, there's still so much more to uncover about this fascinating element.
Absolutely. The world of science is full of surprises.
Yeah.
And holmium is a prime example of how even seemingly ordinary elements can hold these extraordinary secrets.
Well, on that note, I think it's time to take a short pause. We'll wrap up our exploration of holmium when we return, exploring its role in those fascinating lasers and that surprising abundance we talked about. Stay tuned. There's still much more to uncover. Welcome back to the Deep Dive. We're in the final stretch of our exploration of holmium, and before we wrap up, we need to shine a light on those incredible holmium lasers.
Yeah, those lasers are pretty special.
What makes them so unique?
Well, it all comes down to those unique energy levels within the holmium atom.
Right.
When you pump them up with energy,
Right.
they release it as light at a very specific wavelength,
Mm-hmm.
right around 2.1 micrometers.
We touched on this earlier, but I'm so curious why that specific wavelength is so important. You mentioned it gets absorbed by water, which makes it useful for those medical applications.
Exactly. That strong absorption by water, it makes holmium lasers ideal for incredibly delicate procedures.
Okay.
Think about kidney stones, for example.
Right.
A holmium laser can actually break them down
Wow.
without harming the surrounding tissue
Okay.
because it's targeting the water within the stone itself.
So like a heat-seeking missile, but for water molecules.
Oh, yeah, something like that.
It's remarkable how something so precise can be used inside the human body.
It really is.
And that precision isn't limited to medicine, is it?
No, not at all.
We were talking about how holmium lasers are also used in optical fiber communications.
Right, because that 2.1 micrometer wavelength, it just happens to be where optical fibers are most transparent.
So holmium is helping us stay connected in this increasingly digital world. I never would have guessed.
It's amazing, isn't it? It's a testament to holmium's versatility.
It really is. And speaking of unexpected applications, remember how we talked about holmium's role in those super strong magnets?
Oh, yeah, those magnets are incredible.
It's magnets that can withstand extreme temperatures and power these cutting-edge technologies.
Right, and it all comes back to that incredibly strong magnetic moment we discussed earlier.
Right.
Holmium's ability to generate such powerful magnetic fields,
Yep.
it just makes it perfect for applications where other magnets would simply fall apart.
It's mind-blowing how an element that's more abundant than silver can be so crucial to these advanced technologies.
Yeah, the term rare earth really doesn't do justice to holmium's prevalence.
It makes you wonder what other hidden talents holmium might possess, what other potential applications might be waiting to be discovered.
Here's a thought-provoking question for you and for our listeners. Given holmium's magnetic prowess, its ability to control nuclear reactions, and its versatility in lasers, what other groundbreaking applications might emerge in the future?
It's exciting to think about. Perhaps holmium will be the key to unlocking technological advancements we can't even imagine yet.
The possibilities are truly vast, and that's what makes this deep dive into holmium so fascinating. It's a testament to the fact that there's always more to learn, more to explore, and more to discover, even in the elements we think we know.
We've journeyed from those early spectroscopic discoveries in the 1870s
Right.
to the cutting-edge applications of today.
Yeah.
And it's clear that holmium's story is far from over. This element, once hidden in the shadows of the periodic table, is now stepping into the limelight.
And that's the beauty of science, always revealing new wonders and pushing the boundaries of human understanding.
Thank you for joining us on this deep dive into the world of holmium. We hope you've enjoyed the journey as much as we have. Until next time, stay curious and keep exploring the endless wonders of the universe.